Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our modern C++ series. In this lesson, we're going to continue our dive into the standard template library, the algorithms library, and we're going to be looking at reverse. I've seen reverse show up a few more times, so if we look at our container library, for instance, you'll find things like reverse. In fact, let's just go ahead and open up another window here. Vector, for instance. And if I scroll down here, or let's see if I even search it, let's see, can I find a reverse here? I can find the reverse iterators, which will be sort of interesting to look at here. But do I have a reverse function here? Doesn't look like I actually have one in vector. What about for a list? I wonder if I can reverse a linked list. Now, that's a good interview question here, or a doubly linked list. It looks like I can here. Okay, so it's got a built-in operation here. So what I'll say is, generally speaking, to prefer the member functions, as you know, there's probably a reason that somebody went through the trouble of writing this for this data structure, because maybe it's just meant for this one, and maybe it's a little bit more optimized. But again, we do have a generic version of the reverse capabilities when we need so in our algorithms library. So again, reverse, as it implies, we're going to be not in the non-modifying sequence operations, but in the modifying sequence operations. So let's go ahead and take a look here. We've got reverse. Now we've actually got reverse copy here, which isn't really a destructive operation to say, but we will be modifying some other sequence where we have a destination and we want to reverse the elements. So again, just the idea of what we're doing here. If I have some vector here, or some other data container here, 1, 2, 3, 4, and if I do dot reverse on it, and this time I'll actually write reverse instead of reserve if you've been watching my videos, then I will in fact get 4, 3, 2, and 1 in this data structure here. Okay, so we can see that it's been modified. Now reverse copy will actually and let me actually do this properly here. If I call reverse on this, it is modifying it in place here. So let me actually scratch these out here, and I'll have 4, 3, 2, 1. Reverse copy, just to be a little bit more precise here, will actually give me these elements here in a new block of memory here. So 4, 3, 2, and 1. Okay, so that's the difference. Just writing out there. I think you understand reverse. And that applies again, whether it's a list or, as I've drawn here, an array or maybe a vector like data structure. So anyways, let's go ahead and take a look here. So we need a start and a end here. Now we need a bidirectional iterator, so a data structure or container that has random access. So things like vector, for instance, or array should be fine, but we do need bidirectional iterators. So for instance, forward list, again, let's go ahead and look. Now list, of course, is a doubly linked list, but let's look at forward list, for instance. The type of iterators that it has, it's just a forward iterator, so can't reverse this. In fact, if I look and see, does it have a special reverse? Looks like it does have a special reverse, and maybe we'll try it. I'm actually curious what this does. I'm guessing that this just reconstructs the entire list here. Let's see. I guess it's just reallocating it. Maybe. Yeah, that's probably what it's doing here. We'd have to actually look at the implementation here. But we'll try reverse on it. I'm actually curious because it needs a bidirectional iterator here. But anyways, let's play around with this a little bit here. So I'll add forward lists. We take a look at it later, because I like to experiment in these videos. Now, just to make this a little bit interesting, let's put together some of the things that we've seen in the other videos here. So let's, again, start with vector. We'll maybe move to forward list. I've got an int here, so I've got 10 elements here. Let's generate a few, and then let's fill our list here. Okay, so let's use, instead of generate here, let's fill, or excuse me, our vector data structure here. Let's fill it with ones from the beginning to the end. And then from beginning, let's see, +5, the last elements, we will put in the values 1, 2, 3, 4, 5, or something like that. So let's go ahead and see what this does here. If I compile it, it's working. And it gives us a bunch of ones, again, filling in the first values, and then 0, 1, 2, 3, 4 here. Okay. So if you haven't watched those videos on generate or fill, you can check those out in the playlist, or I'll do my shout out here. Just, check out my course webpage. You can track your progress and see if you've actually seen those videos. But anyways, looking at this, that's a reasonably interesting sequence of data that we've got there. So let's reverse it. I mean, let's just go ahead and try here. Now, again, we can do int reverse here. Okay, just call the member function. So let's go ahead and, let's see. Did I spell it correctly? No, reserve. Let's go ahead and see. I think I still gotta use it the same way, I believe, if I've got the member function. Forward list. And let's see. Oh, no, for forward list, I can just do dot reverse here. Let's look at our vector. So we're going to want to look at a few of these for reversing, just to have some completeness here. Oh, yeah, let's see. I guess I don't have reverse in vector, right? That one didn't exist. Okay, so I guess we'll just dive into, well, standard reverse. And without looking at the help page at this point here, let's get rid of our errors. Can we figure out how to do this, right? It's probably going to be from the beginning and, well, to the end. Okay, so let's reverse the whole thing here. Okay, so let's go ahead and compile this and minus little silly parentheses errors. Compile this, run this, and there we go. Now we get our sequence 4, 3, 2, 1, 0, and then a bunch of ones, right? Because we filled the first, or filled all of our data structure here. Excuse me, I went and filled in all of this, and then I overwrote starting from the fifth element here, 0, 1, 2, 3, and 4, and then I reversed it here. Okay, so actually just to make this a little bit easier to parse, let's hold on to this here. Let's actually make this a print function here. This lambda, let's see, auto, and this is just going to take in, let's make it a, let's just work with vectors for now. Std vector of int, and I want to pass this in by reference, and we'll make this const here. That's going to be our parameter. Yeah, let's make this a lambda effectively here. Okay, I could write this as a function, but helper lambda to print things. Okay, and then let's print before. Let's see if I did that properly. Our ints, and let's print our ints after. Okay, just to see what's going on here. And we should probably do like a little thing here. And I'll put a little end here. Let's see, did I do that properly? Almost. Ints was not declared. Okay, yeah, I gotta give this a name here. V. Okay, there we are. All right, so now I can print this before and after. Okay, just so you can see the original 1, 0, 1, 2, 3, 4, and then, you know, that is reversed here. So, okay, not too bad there. Reverse, pretty nice to use. That seems to work quite well here. Now, let's look at the other operation that we have, which is the reverse copy here, okay? So let's see how that one works here. And again, just for completeness, if I'm in reverse, we didn't look at the actual page here. The complexity they're giving us in terms of swaps here. So again, it depends on how many operations we have here. And then it's just swapping or using some sort of, you know, clever algorithm here, right? Finding the first and the last iterator, swapping them, then moving to the next position, and then the second to last element, swapping them, and so on, right? You've got to do that. So it's a linear complexity. So, you know, n over 2 swaps. Okay, so let's consider here. Let's go ahead and take a look here, see if there's anything else interesting. I mean, this is the type of thing you'll probably get asked in some sort of interview, and you'd want to write something that looks, you know, something like this here, where you have, again, if you're using iterators pointing to, again, the first element and the last element, and then maybe you'd write a helper swap function or something. That's probably how I would do this. Or you can write this with the actual loops as shown here, and that's fine. This is a handy, let's take a look at this actually, iter swap here. Swap the values of the elements the given iterators are pointing to. Okay, so that's even kind of handy to know about here. Haven't particularly used that, but it's used in our STL, so that's nice to know about. And here we go here. So you could write your most generic, I mean, this actually might be quite useful in some sort of some algorithms, or just this idea of an iter swap, of looking at values at your iterators, right? Maybe you want to do like a adjacent difference or something and be looking at two iterators that are next to each other and perform a difference. And anyways, different things that you could do with that. Okay. Oh, but they have a little handy print function here as well. So nothing too crazy here, but let's look at reverse copy here. So again, same sort of rules, the bidirectional iterators, and then you have an output or destination. Okay, so you need to be able to write somewhere and copy. Okay, so I believe we've looked at copy if you've been following along with this series. So you need somewhere that you're writing out, but you only need one location here. That's going to be the new destination, right? You got to linearly walk through whatever collection that you have reversed, and then write out that data here. Okay. So complexity and assignments. Yeah, you do the swaps or the reversal and then copy those over. But this is going into new memory. Okay, so you have to assign, if you've got 5 elements at some point. Okay, and as you're doing the swap, so to speak, you're not doing it in the original data structure, but copying over those values. Okay, so let's see. We got a reverse copy here again. First parameters, what data structure you're copying from, and then where are you going, your destination, okay? And then whatever that data structure is. Now, important to observe in this example, destination 3, I can already see here, we have this vector here of 3 elements, right? So you have to match or have a corresponding destination. I'll try this. Let's see if we can break this and do a smaller destination, but let's get this to work first. And what I want to do here, first and foremost, is do a reverse copy. Let me actually preserve this here, just in case you want to see the difference. But reverse copy, and we need some destination here. So let's just create a new, again, vector of int copy, or let's call this like target, or sometimes we would call this, the other thing you might hear this is like the sync, which is how I like to think about things every once in a while, right? Where your destination is. Sync, and let's just put that in parentheses, or destination, sometimes abbreviated DST, depending on if you're like in a C programmer, but we're C++ programmers on this channel at least. Okay, let me compile this. Oops, looks like I haven't finished this. Right, I need my destination. And where am I writing to? Well, the beginning here. That's where I want to start writing. Okay, let's try to get this all on one thing here. Did I do that right? Yep, looks good. Now I run this here. Now, as I mentioned before here, I try to create some errors, sometimes on purpose, sometimes on accident. This is on purpose, right? We don't have anything allocated here. So that's why we're getting the segmentation fault. Where are we writing to here? I'm going to look here and see if our reverse copy has like a back inserter or something. No, it looks like it just takes an iterator here. So we have to have this memory copied here. So given our n elements here, copies elements here to another range of n elements with a destination range first. Okay, in such a way that the elements in the destination range are in reverse order. Okay, let's see. If first and last overlap, the behavior is undefined. Let's see here if it says anything about must have memory. Output iterator. Okay, let's see. Exceptions. Let's see here. I guess I don't see it here. I mean, it just sort of makes sense that, if I look at this implementation here, right, there's no allocation for this data structure. So again, we've got the building blocks, but we've got to actually build this ourselves. So let's see. If I have this target here, I probably want to make it like ints size here. Okay, something like that should do the trick, and that gets rid of our segmentation fault. Now, of course, what I'm printing out here is ints. So what you can see here is, well, if I print out ints after doing a reverse copy, it didn't modify that data structure. Okay, so I see the ones here, 0, 1, 2, 3, 4. It's the same thing. So let's actually print out here. Let's print out our target, which has the reversed vector. Okay, and I gotta make this again yet smaller again, and then I could just call print and our target. Okay, I'll recompile this. Works fine. And now we can see when we print out our target, it is reversed there beautifully. Okay, great. So that seems to be working fine here. All right, great. So the experiment I want to do next here is let's just replace vector with forward list. Let's see how generic this is, because I wanted to do this as an experiment. Maybe this will just break everything. And I'm just going to come in here effectively and substitute out vector with forward list. Let's see if that, without even looking here, compile. Okay, we got some stuff to work on here. So this is why probably we have a special member function for reverse. Now, do we have reverse copy in forward list? Let's go ahead and open this up because we go to forward list and I look for reverse. Okay. No, I don't. Sorry. I do have something to reverse the elements in place here. Which you could imagine, right? Walking through a forward list, right? This is like the interview question. Let's see. Is it giving me... No, it's not giving away the answer here of how to reverse a linked list. You'll have to do that on your own here, right? With a doubly linked list, it's relatively trivial, right? To swap those nodes. But let's see. So what can't we do here? Well, we can't reverse our copy. Yeah, let's get rid of the errors here. If we want to do the reverse, let's see here. Let's see, that might have been the only thing that was going crazy for us. Oh no, size, right? Let's get rid of that here. And let's just do our reverse here. Int reverse. Okay, let's see here. Oh, and we don't have a target here. But we can print out ints. Okay. Oh, what else are we missing? Oh, in our generate n function. Let's see here. I can't just do +5 because I don't have a random access iterator. But let's see if I can use generate here. I can. Okay, no errors. And here we go here. Okay. So I have our... Let's just do a recap here so I show you all the code. I just replaced our vector with forward list, which we could still use with these other things that we've learned, like fill. Again, I get, let's see, I filled this with ones all the way through, and then I filled our first few numbers with 0, 1, 2, 3, and 4, and then the remainder of ones that I already, I filled in everything here. And then again, I come down, and after I print out my ints here, then I reverse it, which is a special member function. And again, I mean, sometimes we can call this, sometimes we can't, right? So I mean, here's our ints reverse member function. Here's our generic one. And again, that one goes and crashes, right? It's saying, hey, if we read this, it can already kind of tell here we need some random access iterator, which again was the requirement for both reverse or bidirectional one. Okay. Let's look up on the iterators, just again to give you, if you haven't been watching this series all the way through, right? This is the important table to look at. You can kind of see what the power is here, right? The simplest things are, having iterators that just effectively like move forward. Okay. And then bidirectional, well, you need a few more operations that if you want random access, right, you need a little bit more power in that data structure. Things like vectors, for instance, would be most flexible with how you can iterate through them. Okay, so anyways, with that idea in mind, that's why you sometimes find these special member functions for these things like forward lists. So that's why we have to use, dot reverse here. Okay. So anyways, that's again just showing both the different data structures, why you sometimes have those member functions. Usually they're either optimized or you just need them because there's not an iterator that supports that particular operation. Okay, I'm going to go ahead and set this back to the Vex example. Let's go ahead and actually let's leave both here just in case you want to see both. But I'll comment out the forward list here. Implementation for now. And then we'll just scroll through this one more time. Okay. I got to make everything a vector here of ints. But again, I just want to you to be able to see these side by side here. Okay, we already did that here. Reverse. So again, this was need to use for forward list, the special member function, because we don't have, oops, spelled some of this wrong here. Because we don't have the iterator category power. I guess you could sort of think about this. All right. Anyway, I think you folks get the idea here. But again, a nice reason, again, as always, to use the standard template library. Relatively easy to swap these data structures in and out. Let's see, did I get everything? I did. And let's reverse that vector one more time here. And let's see, I did the actual reverse that was destructive. And then we have reverse copy here. And let's go ahead and print that one out as well, just so you can see the target. Alrighty, folks. So I think that's a relatively complete view of reverse. So obviously use this if you need to reverse part of a data structure or all of it. Most commonly, you're probably going to be using this to like reverse keys or something if you have a dialog, if you're sorting some data. Again, that's a sort of common use case where I'd be using this type of thing. Maybe you have other more interesting things where you have like some sort of inverting operation, right? If you're reversing a vectors of zeros and ones, right? And can kind of apply some sort of operation after that. That might be a reason to use, like if you have a mask or something or a stencil in like graphics programming, that would be another, quick use of reverse. Anyways, folks, with that said, check out the lesson on courses.msha.io. Hope you enjoyed that. Comment below if you have other questions about this reverse algorithm. And otherwise, I'll look forward to seeing you folks in the next lesson. Thanks for your time and attention as always.